In this video, we'll just continue our discussion last time. This time, we're going to graph particular examples of logarithmic functions. Take note of remark 5.2. We will use this idea to graph our logarithmic function. So again, for remark 5.2, the idea is we're going to use the exponential function, the equivalent exponential function, or that's the inverse, okay? And logarithmic, uh, we will use that exponential function in order to graph our logarithmic functions, because it's quite easy to graph the exponential function than the logarithmic. So since there are inverses, so we will use the exponential function and then use line y equals x as our reference for our reflection to graph our logarithmic functions. So example, we have one, graph the logarithmic function defined by the following. So take note that for number one, um, uh, the equivalent or the inverse uh, of this function f defined by f of x equals logarithm of x with base 2 is, so remember this one is just y, alright. So here we have y equals base 2 raised to x. So what we'll do here is that we are going to use this one. We will use this one. Let's graph the function defined by this and then use this line and then use the reflection in order to find or to sketch the graph of this. Okay? So for number one, so that is y equals logarithm of x with base 2. So the inverse of this is again y equals 2 raised to x. So we will graph the function defined by this first, okay? So how does it look like when your b is greater than 1? So the graph is an increasing function, okay? And our x-axis is the horizontal asymptote. So that's the graph of y equals, the function defined by y equals 2x. Okay? So now we will use this line having an equation y equals 2 raised to y equals x. So now the graph of this is the reflection of this blue function. So which means it looks like this. And remember, for the logarithmic, the y-axis is our vertical asymptote. Okay? So this is now the rough sketch of our graph. So we're done. Okay, next example, number 2. It's very similar. The graph is y. The graph or the equation for the logarithmic function, we have y equals log logarithmic of x with base 5. So the inverse of this function is the exponential function defined by y equals 5 raised to x. Okay. Remember our discussion above? Okay. As well as for this. Okay. So first we will define the function defined by this. We will draw the y equals x. That's the line y equals x. We will graph this one. So how does it look? How does it look like? A little bit steeper. If you can still remember how to graph the exponential. So anyway, this is just a rough sketch. So meaning the graph of this function defined by this is a reflection of that blue curve. So it's not perfect. And its vertical asymptote is the y-axis itself, because that's the characteristic of a logarithmic function. It has a vertical asymptote. In this case, y equals 0, except when we have translations later. So the asymptote will move to the right or to the left. Okay, so now the graph of this equation is this one. And so we're done. We can confirm this one using our graphing calculator. First, we will confirm the appearance of this. Okay, and then we will also graph this one, so that we can see precisely the relationship of these two functions defined by this one. So we'll open our graphing calculator. So we will graph y equals 2 raised to x. Okay, so that's the graph for y equals 2 raised to x. Now we will add another function, which is its inverse, which is y equals the logarithm of x with base 2. With base okay, as you can see, there are indeed inverses of each other. We can also add the line y equals x. Okay, as you can see, the green curve is a reflection of the blue curve with respect to the red line. Okay, as you can see, for number 1, yes, these are the graphs. Okay. But most importantly, the graph of y equals log of x with base 2 is this blue curve. Okay. And similarly, we can also verify number 2 using that uh, calculator or any type of graphing calculator that you have. So the point there is uh, they're inverses of each other, and we've also shown the graph of y equals log of x with base 2. Okay? Now let's move on to uh, the properties of logarithms. So property 5.3. First property, that's I. Logarithm of 1 with base a. Okay, remember our a should be, by definition, the b here should be or the b here should be a positive real number except 1. Okay, so again, there are two cases between 0 to 1 and b which is greater than 1. Okay, so uh, remember the value of a here is greater than 0, and of course our a should not be equal to 1. Okay, so why is it that the logarithm of 1 with base a is 0? By definition, because by definition you will see that this expression is just equivalent to this because of this if and only if. So y equals the logarithm of x with base b. Here, if you're going to convert this to its exponential expression, so this becomes your x here becomes our answer, your b is our base, of course, and the y is actually our exponent. So for the answer for the logarithm, it implies that the answer for logarithm is an exponent. Okay, so here we have, to be able to explain why the logarithm of 1 with base a is equal to 0, just simply convert it to its equivalent, which is the equivalent of this expression is with base a with exponent 0 is equal to 1. Oh, yes, indeed, this one is true. Whenever our a is not 0. So, of course, a is not 0. So, since this one is true, therefore, this one is also true by definition of our logarithms. Similarly, so meaning this one, for the logarithm of 1 with base a, that's always equal to 0. Okay, for 2i, we have the logarithm of a with base a is equal to 1. So we will explain this one in a similar manner, just like we did in I. So of course, the equivalent exponential equation is of course our base a. So we have our base a with exponent 1 is equal to a. So indeed this is true, right? Because a raised to 1 is equal to a. So since this is true, therefore this one is also true. So meaning the log of a with base a is equal to 1. So remember these equivalences, we will use this later on. Okay, do not forget this one. Okay, next is we have this, another property. Anyway, before we proceed, let me give you an example for I. So of course, if we have log of 1, let's say, of base 5, that's always equal to 0. Okay? Or log of 1 with base 1/2, that's always equal to 0. And so on and so forth. For 2i, we have, let's say, we have the logarithm of 5 with base 5, that's always equal to 1. Logarithm of 1/4 with base 1/4, of course, that's equal to 1, and so on and so forth. Okay? So that's properties 5.3. For property 5.4, we have this one. So if b is raised to, so this is the exponent, okay? If b is raised to log of m with base b, that's always equal to m. Okay? That is equivalent to log of b. I think I have some clerical error. Okay, it's okay. So we have b. Why is it equal to a? Why this one is equal to m? Because if we're going to convert this one to logarithm, this becomes, of course, the exponent is the answer, right? Log m of base b is just equal to the logarithm of the logarithm of m with base b. So the logarithm of m with base b. Indeed, they're just the same. Okay? So that's why if you can see this kind of expression, this is always equal to m. Okay? So b raised to log of m with base b is equal to m. Okay? So if they have the same base right here, okay, so that's equal to m. Of course, we will show also that why is it the logarithm of b raised to r with base b is equal to r. So that is why is this equal to r? We will convert this one to exponential. So remember, this one right here is our answer. That's b raised to r. That's equal to the base b with this one. This is actually the exponent. Okay, so that's b raised to r. So indeed, they are just the same. So if you can see expressions like an expression like this, so if we have a b here as our base, This is our answer. This is our base. That's always equal to the exponent. Okay, so just remember all of these properties, because we will use this one in our simplification of some expressions, or even in our when we deal with equations involving logarithms. Okay, we have some examples here. We're going to simplify some expressions. So for number 1, we have 3 raised to log of 5 with base 3. So it is obvious that we are going to apply. So for this expression, we will apply property 5.4. So if our b here is 3, log of 3 raised to 5. So of course the answer is m. So meaning the answer is m. So in this case, the answer will be equal to 5. Now how about this one? We will apply the second part. So to simplify this one, this expression right here, we will use this one. So as you can see, this one is in this form. This one is in this form. So we have the b. So that's equal to r. So which means our answer is negative 3. Okay. So before we proceed to number 3, allow me to go back, because I forgot the case wherein our we've already knew that the logarithm of x with base b is equal to y. What if your b here, or the base itself is e? And remember, e is not a variable, that's a number, that's Euler's number. That's 2.7 something. So now this expression above becomes, okay, this one becomes log x with base e, that's equal to y. Now instead of writing log e, it has some special notation. So we will write now, instead of log with base e, so let's write it as ln then x. So that will be equal to y. So if you can see this expression, this function, okay, ln, it means that the base is automatically e. Okay, all right. So now this one is called the function defined by this one is called the natural logarithmic function. So a function defined by this, so meaning is called the so a function defined by this ln x equals y, that is called the natural logarithmic function. Okay, just like our natural exponential function where our base is e. Okay. Okay, so now let's go back to Uh, Number 3, what if uh, the given is ln of e raised to 4t? Okay, remember that the base of this is actually, so this one is actually equal to log of e raised to 4t with base e, right? As we have discussed previously. Just equivalent. So this one is just this one. So remember, this one is this one. So the answer now is this one. So that's how you simplify using these properties. On the third part of our video, we will discuss more properties of logarithms, and then we will simplify more expressions involving logarithms. So that would be all for this video. Thank you very much and have a nice day.